HVAC 360 is brought to you today by Three Little Pigs Construction Snacks. Celebrating 500 years since the incident with the wolf, we proudly announce our latest snack, Pretzel Bricks. These delicious morsels of sourdough goodness are sold on little pretzel pallets and are located in stores next to the standard packages of pretzel sticks and pretzel straw. Want to build a memorial vignette? Grab some peanut butter and melt some chocolate, but remember to take your time so as not to accidentally huff and puff some of your creations to the ground. Pretzel Bricks may not be gluten-free, but are definitely kosher and vegan approved. Grab a pallet today. Please build responsibly. Hey everybody, welcome back. Matt Nelson here, your host for HVAC 360, helping you be the best and the brightest in HVAC. Each week I'm either sharing information and lessons learned from the field or talking to industry experts. But I don't really want you to stop there. I encourage you to double down on your weekly dose of HVAC knowledge by hopping on over to HVAC360.com and joining my growing community of people just like you. People who want more information about HVAC, who just can't get enough. As an added bonus, you're going to be one of the first people notified to free webinars that I'm rolling out in early 2019. So, what's up for this week? This week, I just wanted to share some information about outside air monitoring station, outside air measuring stations, whatever you want to call them. And I had a couple projects recently where I really kind of got into the nuts and bolts, and I just wanted to share that with you. Just as a separate side note, these things also typically, depending on the type and variety that you get, can also measure temperature, but I'm not really covering that today. Mostly because temperature controls contractors typically have that covered with a separate device. All right, so let's get into outside air monitoring stations. So why use them? So like with any device, we want to know more information. We just want to get more information. This particular device gives us the flow, so we can ultimately get the CFM, the cubic feet per minute of airflow. You know, there's different ways to do this, and airflow measuring stations is just one of those. Sometimes when you go and look at the supply airflow for different air handling units, all that is just a sum of the bunch of little different airflow monitoring stations on the VAV boxes themselves. So they really just sum up that. You can get the total of a unit just by doing that, and obviously another option, if you have more of a constant volume unit or something that doesn't have VAV boxes, you could put an airflow monitoring station in that. A lot of times it's not so much about the supply airflow though, it's more about the outside air. They're usually, engineers are more concerned about the airflow monitoring station of the outside air to make sure that they're getting enough of air in the system. So that's typically kind of why they use them. So what really is going on when you put in a outside air flow measuring station? Typically, they come in two varieties. They come in the fancy thermal dispersion type, and that's the type that I've seen a number of recently. And that is basically what the thermal dispersion is doing. It is the fluid, the airflow. This can also work in water, so it's just fluid in general, whether it's air or water. The fluid flow acts as a cooling across a sensor. Think of it like a hot wire anemometer. And it gives you a reading in feet per minute because it knows what that cooling rate is, what that corresponds to in a cubic feet per minute. And again, obviously you can see where cooling there will also give you a temperature, so that's where they get the temperature. All right, enough said about temperature. But so that's what it is. It's at different points, and they're getting that across a grid. The other different variety that you can get is a pressure velocity. Now, this is just, you go back to 101, Ductwork 101. This is total pressure and minus static pressure, and you get your velocity pressure. So you put in put that through a little calculation with some constants, and you can get feet per minute. So that's ultimately, that's what you want to do. You want to get a feet per minute, and then you know the area of the ductwork, and you can just output the CFM. So that's how you, generally speaking, that's how you get it. Now, the velocity pressure probes that you can find, those are a lot simpler, and that's basically, they don't have a lot of fancy electronics that are connected to them. Typically, they're going to have some sort of pressure transducer, so it's going to give you a signal of what that velocity pressure is, and then your building automation system is going to have to make that calculation internally. Whereas if you have some sort of thermal dispersion, from the ones that I've seen, typically they're going to do an internal calculation. You're going to set the actual area of the ductwork in that the measuring device that comes with the thermal dispersion unit, and that's going to be able to calculate CFM directly for you. So that's what it's going to output. It's going to output the CFM of the fluid flowing across the duct. All right. So one thing that you have to remember is that more sensing locations really improves your accuracy. More sensing locations, better average, makes sense, right? Also, this is, again, getting back to those VAV box flow rings. These are some of the devices that you're going to find already come with, and they're usually more the velocity pressure variety. They're going to come with flow rings. So VAV boxes have these airflow measuring stations, in the throat of the neck of the VAV box. I've seen some on air handling units where they actually come with the pressure, the velocity pressure measurement probes already installed. But generally speaking, when I'm talking here, these are going to be kind of third-party devices that you're going to have to put into ductwork, whether on a new project, or you can even, if you have a existing project, you can retrofit these into existing ductwork. So most of the airflow monitoring stations that I'm going to be talking about are separate. Now, who makes these? Typically, I don't really talk a lot about these, and I'm not necessarily endorsing any one of these. But I know that Ebtron makes airflow monitoring stations. You got Onacon making them, and Ruskin. So if you want three varieties, or at least a starting point to kind of continue your educational journey, this is but a starting point. So you want to go and you want to take a look at what's out there. If you took a look at those three manufacturers, they give some pretty good information out there. I think Ruskin probably, if I had to judge the three, Ruskin happens to have the best educational material. The rest are more in print. So if you want anything sort of like videos, I did watch some videos from Ruskin. Some of them are kind of cheesy, some of them are informative, but I will post those in the show notes, and that can be at hvac360.com/121. So this is episode number 121. So that's how you get to those show notes pages. So I'm going to provide a couple of links of different things that I've found on these airflow monitoring stations. So some of the form factors that these companies provide, generally speaking, they come in sort of like a duct rod. It's an insertion tube that you put on the side of the ductwork. That's going to be, the orientation is very critical on these. Obviously, it has to go in the direction of the airflow, so that's rather important. You can't just kind of flip these things around and expect them to work. They only work in one direction. So there's different. And again, when you're ordering these are not a one size fits all. They are very custom. They're a very custom form factor. And a lot of times, especially the ones that I've seen, it is a specific size of ductwork. So it's, a lot of times, especially when you get to the calibration stage, it's, depending on where you're putting it, it's pretty darn close to, being spot on. So you can have them installed in large ducts, small ducts. They come in different lengths. Sometimes you might, depending on the size of the duct, you might have one of these tubes put in the side of the duct. Sometimes you're going to have 2 or 3, and that all depends on the number of points that you want to gather and the average. So size of the duct, all that matters. Other things, other form factors that you can do, the small rooftop units or ERV units, they also have some sort of device that you can install in the inlet that will measure the airflow. And again, we're measuring velocity here over an area, so that's how we get the CFM. So it's nothing really magical. Other things that they do, they actually have frames. So if you don't want to install, and typically when you're installing the tubes, you're going to drill a hole on one on either side, and you're kind of slide the tube across. If you know the size of the ductwork, you can actually just cut a slot on one side of it and just slide this frame in, and the frame already has these sensing rods already in them. So there's really nothing to do. I've seen some of these frames too that actually come with an integral damper. So you can have, it's already calculated. You don't have to worry about damper interference, which is sometimes a problem. And that's another thing that you can have. Other things, fan inlets. You can have them on fan inlets, and they're they look a little bit different. They're smaller tubes, but again, depending on what the diameter of the inlet is, you can do a calculation, and you can do not only just one or double width, double inlet fan. You can do fan arrays with these things, so you can have multiple fans on the same monitoring station and do it that way. So again, kind of whether you're in a ductwork, whether you're in an intake hood, whether you're, you just want to slide a frame or need an integral damper, that's another form factor. And then the fan inlets, that's kind of the scope of things. I'm sure there's some other different special use cases, but generally speaking, this is what you're going to see out there. Most of the stuff is either going to be a frame, a fan inlet, or it's going to be one of these sensing tubes that gets installed into ductwork. All right. So what happens at each stage of the game? Really, the first stage, obviously, is design. And what are you going to be, the important thing to think about as an engineer is what are you really going to be using it for? Is it going to be for just a data point that you want to know about? Is it going to be for a control sequence? Is it going to be just a verification that you're getting something right, like the required amount of outside air for a particular project? It's important because these things can be expensive. When we're talking about the thermal dispersions, those are and I haven't priced them out, but I know from the equipment. I look at the equipment. The thermal dispersion airflow monitoring stations are much more are very expensive to put in. So know what you want to do with those specific points of information. Sometimes I'll see them control the outside air damper. Like a lot of times you're going to be measuring the airflow and you say, okay, here's my minimum. I need to increase it or decrease it based on the amount of airflow that I'm getting into the system. And other times you were going to use them. I've seen them for pressurization, to put a return fan speed offset to make sure that you're maintaining building pressure. So there's a lot of different things that you can do with the airflow monitoring station, but just understand, what you're doing with it. It's very, they're very touchy. They can have a lot of, back and forth. So really kind of nail this down. If you're using the airflow monitoring stations as a point in your control sequence, so it's controlling something specific, whether it be a damper or whether it be fan speed, be very careful because it can go very wrong. That's one of the lessons learned that I'll talk about a little bit later. So let's jump into installation. So it's with any airflow measuring. Any measuring device, location. It's very important. You want to be able to get that laminar flow. You don't want that turbulent flow around these airflow meters. Again, they're unidirectional. So when you get this kind of this tumbling, turning airflow, it's not going to necessarily read correctly. You're going to get some false negative readings. A lot of times, and you can take a look at it. A lot of times they're going to have recommendations based on what your ductwork configuration is. So if you're an engineer and you're looking at this, take a look at those recommendations, those guidelines. Typically, they're going to be 1 duct diameter, 2 duct diameters, 3 duct diameters. Sometimes it's going to be 5 or 10, but typically it's going to be in that 1 to 3 range, depending on what your upstream condition is. As far as calibration, so you've installed the ductwork, you got it in a good location. Let's talk about calibration. I guess the 2 areas of calibration, again, they know what the velocity is. All these things have been calibrated. So it's really the change in, is it the right, is the exact duct dimension? Did they get that right? And like I said, sometimes they can be really, really close with this. But the only way you can do that is calibrating it with a test and balance authority. So you're going to get your tab contractor in there to do the test and balance to verify that, with their calibrated equipment, they're going to verify, yes, we're getting this sort of velocity. They know what the duct dimensions are, and they're going to do their own calculations, and you can compare the two. You're going to say, okay, this is what the unit is reading. The monitoring station is reading. Here's what I'm getting from my test and balance agent, and you're going to calibrate your equipment there. Either you're going to do that with, putting in a K factor. A lot of times, especially VAV boxes, use K factors. I know that a lot of these thermal dispersion arrays don't use K factors. Instead, they just use the duct area. So you're going to have to manipulate the duct area in calibration, and you're going to have to adjust it a little bit. So generally speaking, that's how you calibrate it. Now, as far as commissioning goes, as being a commissioning authority, you want to be there when these things get calibrated. You want to understand, okay, what was the square, footage that they kind of, had originally? What did you change it to? You want to make sure that's documented. Even if you don't document it, maybe, because they come with tags. A lot of them, these Ebtron units that I was looking at, come with tags that show specifically exactly how it was set up. So you want to be able to note that information on the tag saying, here, this is the square footage that we used when we calibrated it. So they know what it was changed to, because typically it's going to have the factory setting on that tag. You want to be able to judge, is this going to be a best location for it? Is it the right location for it? Are we going to get good readings from it? And generally speaking, by the end of the commissioning process, you're going to have a good idea whether or not it is a good location. And, if it's not, again, these are expensive. So it could, ultimately just be a waste of money. Which is kind of a bad situation to be in. And that's why you want to be so careful when you take a look and, you're spending the owner's money. You want to make sure that these are as reliable and valuable as possible. And even getting back to the design, you want to make sure that if there's something you want to be able to spot it on a drawing. You want to be able to make sure that you have enough duct length, and you want to be able to spell that out maybe to the contractor. Because again, a lot of times you're going to say the drawings are diagrammatic in nature, but if you say, hey, I have an airflow monitoring station and I need this much duct work, and make a special note of it. It's a signal to the contractor that you have really carte blanche on kind of redesigning the system to some degree, but you really need this upstream. It may seem like wasted ductwork or additional ductwork that you don't need, but it's really critical to the being able to measure the velocity at this location. So, identify that, make it a special item, circle it, bubble it, whatever you have to do to kind of say that that's really critical. Just don't necessarily, you can have a detail on it, but just don't leave it to the detail sheet, because, that in general, they probably wouldn't look at the detail sheet when they're making the final duct layout, but they'll look at the plans, and then if it's on the plans, they might take it, they might not take it, but they at least you give it a fighting chance to get a good location for that airflow monitoring station. And then you're going to, as commissioning, you're going to do perform some logic tests. You can shut the unit off. Does the airflow monitoring station go to 0, or does it not? And if not, why? If you're going to open up the unit to full capacity, what is that capacity? Does that match the design capacity? Is that relevant? So there's some different data points you can get, performing some certain logic tests with these monitoring stations. And then if you have a sequence, if these airflow monitoring stations are involved in a sequence, then obviously you want to be able to verify that control sequence, that it's doing what it should be doing. So what are some of the lessons learned that I took out of, that I've learned from airflow monitoring stations? Well, one of the things is that depending on the space constraints, you may be upstream or downstream. When we're talking about the outside air damper, you might be upstream or downstream of an outside air damper. And what is that going to be, as far as turbulence? Are you far enough away from it? Where are you relative to the return fan? Is there a return fan? Are you close to the outside air opening? Are you going to get turbulence? And that's ultimately where you want to be understanding. Because if you have turbulence around a fan or around one of these flow measuring stations, you're not going to get, like I said before, this is going to negatively affect the readings, the installation. You're going to have this twirling wind. It's not going to be the best location, and you can get that simply from being too close to the outside air damper, and it just kind of blowing. I had a situation where the outside air damper I know was closed, and I had the monitoring station but upstream, so it was exposed to the outside air. And there was, blowing and, swirling of air, so it never really got to 0. And that's, it just had to be explained that way. So why wasn't it 0 and the outside air damper was closed? And I had situations where completely the opposite was happening, where I had it downstream of the outside air damper. And when that was closed, you would see a value for that. And why was that? Well, the return fan in this case was pushing air, and it was just swirling air around, and it was just reading way too high, even though the outside air damper was completely closed. Sometimes you can kind of mitigate the amount of air movement in a mixing plenum. So you could actually put some sort of a sheet metal baffle in there, but that's really kind of a contractor fix to be able to address this kind of issue. So again, kind of fair warning, be careful. If you're putting them in, where you're putting them in, take some special precautions. Try to get it in the best place as possible, because again, once you put it in, the ductwork is in. You're not going to change the ductwork. You could possibly change the location of where the airflow monitoring station is, but you're not going to change the ductwork too much. So if there's no good location, you might have well just thrown away some of the owner's money. And if the owner is very savvy and they're looking at this, it's going to be a black mark upon your design and how you laid this thing out. So, also existing conditions. We had cases where we had existing ductwork, and I found that the airflow monitoring station was installed in the wrong ductwork. Side by side, the supply air ductwork looked like the outside air ductwork. Everything was insulated, and the contractor simply put it in the wrong duct. So that, through the commissioning process, you can kind of understand where everything is going. The drawings may not be the greatest in some of these existing condition locations. So, it's completely understandable. It's where you can get access to, where you can put these in. And again, that really determined in this particular case where you could actually install this airflow monitoring station, because there wasn't access just everywhere. You had specific locations, and that was was it. Because of other ductwork, because of other piping, there just wasn't a way to get in to specific locations for the ductwork. And last thing, kind of along the same lines of the using it in a control sequence. Again, you have fans that are hunting. You can do hunting fans, hunting dampers. If you're using it in a control sequence and you have the outside air, the airflow monitoring stations, updating fairly regularly, sending that off to the BAS, it could you could have your fans just trying to just all over the place with the control, and having hunting fans and hunting dampers constantly changing speed, constantly actuating, constantly changing. It just isn't good. Obviously, you could put a internal dampening, PID in the sequence, but sometimes that's not always the an available solution. So again, just be careful what you're using these airflow monitoring stations for. All right. Thanks so much for listening. I hope this was helpful. If you know somebody who's looking for more information about this topic, consider passing this episode along. If you're not a subscriber yet, I would implore you to join the growing community of people just like you over at HVAC360.com for some more weekly goodness. Lastly, I would be greatly honored if you go and leave me a rating on Apple Podcasts. It helps the show become more and more recognized. Honestly, if you do that, that would be great. A lot of this, pass it along, share it with people, let them know it's an available resource. I try to put as much content out here for free as possible, and really by spreading the word, you're doing the most good. Sometimes the way engineers communicate just isn't the greatest, so I want to make sure that everybody's aware of this content, and that they can listen to it, and they can give me feedback if you want. Send me an email at matt@hvac360.com. Not a problem. I love to be answering those questions. So that's a wrap for this episode of HVAC 360. I'm Matt Nelson, helping you be the best and the brightest in the field of HVAC. And as always, know what you build and share what you know.